All right, 8th graders, we're back with some angle measures. We're going to talk about how these angle measures correspond and how they work together. We're going to develop these a lot more in future lessons, but this first chapter is really just kind of touching on some basic pieces, and then it'll all come together. So we're going to measure and classify angles, and we're going to identify and use congruent angles and the bisectors of an angle. So classifying angles, we mean obtuse, acute, and right. So right is 90 degrees, acute is less than 90 degrees, but more than 0. And obtuse means that it's more than 90 degrees. So we got that down. So an angle consists of two non-collinear rays. So not the straight line, not the same line. All right, rays have an endpoint and go on forever in the other direction. All right. The rays are the sides of the angle, and the common endpoint is called the vertex. So we have right here, notice, and it's hard to see, I'm going to make this a little bit better. The angle has these sides. Ray MD should have an arrow on the end. It's really hard to see on the screen. And ray MU. When you name your rays, you start with the vertex and you go through the other point. So both of them start with M because M is the end point. MU, ray MD. You label it with an arrow, and the arrow has to face to the right. Point M is the vertex. It's where those two rays come together. That's the vertex. So now the angle can be named, in this case, it can be labeled angle M. The reason it's okay to label it by the vertex is because there are only two rays that go from that vertex. If there were three, we wouldn't be able to name it as just the vertex. Because there's only two rays, we can call it angle M. We can call it angle UMD, or we can call it angle DMU. And again, we want to make sure that this middle number is the vertex. So UMD, DMU. All right, something that would not work is UDM. That does not work because D isn't the vertex. It can't be in the middle. So these are the parts of an angle. It's two non-collinear rays, common endpoint, the sides are rays, and the endpoint is a vertex. As always, pause the video as you're going through if you need more time to write down. All right, so how many angles? This is a case where you can't just label it angle E because there's more than two rays. So all these angles that we can name on here. We have angle TER. We have angle RET. Two names for the same exact angle. We can call it angle TEP or angle PET. We can call another angle REP or angle PER. We could say angle 1 because there's a 1 in here. That's the same, these are all the same angles. We could say angle 2. Those are all the same angles. So those are all the different angles that we can name in that particular picture. R is on the interior of TEP. That means here's my angle TEP. R is on the inside, S is on the outside. R is the interior, S is the exterior of angle TEP. When you name your angles, you put the angle symbol in front, you make sure the vertex is always the middle letter. Always. These are all different names that you can label these angles. All right, so when we're taking a look at this, angles are measured in degrees. With a protractor, we are not measuring anything with protractors. If I make a mistake and accidentally assign something where it says, hey, measure this angle with a protractor, don't do it. I made a mistake. We're not doing that, okay? The notation, again, notation is so important. I'm going to be super picky on it. So I really need you to pay attention to details. So if we have an angle that measures 112 degrees, we put the M in front. The measure of angle ABC is 112 degrees. The measure of ABC is 112 degrees. Okay? If angles have the same measurement, they're called congruent. And I'm going to pull this down here. I'm not sure why that's boxed in. Again, looking at labeling. The measure of angle GHI is equal to the measure of angle QRS. We can also then say that angle, so this is naming it, this is measuring, that angle GHI is congruent to angle QRS. Naming it matters. Pay attention to the details. Congruent statements are names. Equations are measurements. These two represent measures, actual numbers. All right, so some vocabulary. We have something called an angle bisector. Bisect means to cut in half. So it's a ray that cuts an angle in half. That's what an angle bisector is. All right, it's a ray that cuts it in half. We use these symbols to show you that there's the same. We never, ever say it looks like in here. We've got to have proof. It doesn't look like they're the same. We have to have proof. And in a picture, this is how we have proof, right here. These symbols mean congruent. So we could say that angle WOR is congruent to angle ROM. Or we say that the measurement of angle WOR is equal to the measurement of angle ROM. Notation matters. How you write it out is important. Let's try one problem before we get you going. Okay, or two, I'm just kidding, two, I lied. So if the measurement of angle Shopper made a mistake. It's WOR, you always have to have your vertex in the middle. All right, if the measurement of angle WOR is 37 degrees, let's say this is 37 degrees. What is the measurement of WOM? Okay, so I know that this is an angle bisector because these two indicate that these are the same. I want to know the measurement of WOM. If this is 37 degrees, then this is 37 degrees. And I can add these two measurements to get the whole thing. So the measurement of angle WOM is 74 degrees. And looking at this last one, we're pulling some algebra in here. Again, we're going to keep tying in. You're going to use a lot of algebra. We want you to see how that algebra and geometry go together. They're not standalone classes or subjects or contents or whatever you want to call them. They really are integrated, and we're going to continue to show you how that happens. So if WOM, so this whole thing is 3x plus 15, and WOR is 2x minus 7, what is the measurement of ROM? So I know that the measurement of WOR is the same as the measurement of angle ROM. That I know. I also know that 2 times the measurement of angle WOR equals the measurement of angle WOM. So what I can do is solve this equation. So 2 times the measurement of WOR, which is 2x minus 7, is equal to the measurement of WOM, which is 3x plus 15. So I've got 4x minus 14 is 3x plus 15. I'm going to subtract 3x, add 14, so I get x equals 29 degrees. If I know that the measurement of WOR is equal to the measurement of OROM, I can then put 29 in for x and solve it out. So 2 times 29 minus 7 is equal to the measurement of ROM. So 29 times 2 would be 58, minus 7 is the measurement of angle ROM, so 51 degrees is the measurement of ROM. We're applying algebra, we're using algebra to solve this out. Okay, this video got a little bit longer than I wanted, but there was a lot of information to get to. So thanks for hanging with me, and until next time.